Textiles that are made up of yarns with conductive material. We make them at our own Textile Design Lab, or TDL, at AUT. Looking up real close, you could see that the textile has conductive material interwoven with the yarn. In the case of the textile you see in front of you right now, it has stainless steel used as a conductor. Hi, my name's Yasser. I'll show you how I went about characterizing what we nowadays call E-Textiles. LabVIEW is what I use to log the impedance of the textile. It's a versatile software that you could use to interface with many meters and equipment. Just put in a live waveform, connect the data to the waveform so you can see what's happening in real time, and you have yourself a software that can log various impedances with controllable voltage and frequencies, and writes a report in the end to Excel with processed and unprocessed data. Now let's wire everything up, starting with the LCR meter's GPIB interface that LabVIEW uses to talk to. Turn on the LCR meter, select the correct instrument with the LabVIEW software we just made, on to hooking up the hardware used to test the textile. Polyethylene bases are used to insulate the clamps holding the textile from the rest of the machine. These aluminum clamps are held apart on a spacer when clamping the textile, to ensure the same length of textile is being tested for each test. These blocks are what hold the textile and complete the circuit for the LCR meter to log impedances. The clamps are then slid into the clamp holders and then turn the texture analyzer on. Launch its software called Exponent, raise the clamps to a set height of 210 millimeters, set up the parameters of the test such as strain, distance, and force, plug in probes for the LCR meter clips to attach to, and now to get some visual data. We hooked up a camera with super macro lens to look closely at the textile as it's being tested. Finally, a DAC card is attached to the texture analyzer to time the logging of the impedance with everything else in the test. This completes the setup. Let's see what we can get. Here demonstrated, you could see all the parameters that are being logged for the test. This is to help us understand why the impedance behaves the way it does. Now that we've acquired the data for the set sample, let's go ahead and see what we can do with this data outside the lab. In these plots, we can clearly see a relationship between logged impedance and the distance the textile travels, or strain that's being placed on the subject. Here displayed is the normalized values of 3 sets of data, showing that there's an interesting relationship between them.